A video to help you with the Chapter 3 review, since I wasn't here during intervention on Friday to help you. I'm just going to skip around. I'm going to do a few problems, and I'm going to go very quickly. I'm not going to do every problem. First one I'm going to start off with is number 1. They give us a picture. It looks something like this, and you can see the picture there on number 1. We know that these two angles are vertical, so they have to be the same. And these two angles are vertical, so they have to be the same or congruent. And just looking at it, you want to try to set up something that only has one variable in it. Well, they tell us this angle is 8x plus 90. This angle is 7x plus 30. And we know that those two angles are a linear pair, so they have to add up to 180. So 8x plus 90 plus 7x plus 30 should equal 180. Alright, and the other angles they tell us, like this one down here, is 4y plus 54. Well, we probably don't want to set up this equal to that just because it's got an x and a y in it. So if we solve this, and again I'm going to solve these extremely quickly, just collect like terms there, then subtract 120 on both sides, that's 15x equals 60, end up with x equals 4. Then once you figure out that x is 4, you can stick it back in here somewhere, like I could stick it in right here and say 8 times 4 is 32, 32 plus 90 is 122, so this angle is 122 degrees. That means this angle has to be 122. So 4y plus 54 equals 122. Subtract 54 on both sides. These cancel out. You're left with 4y equals, if we borrow it here, make that a 1. That's an 8. Then we borrow it here, make that 11. That's a 68. We want to divide by 4. Y equals 4 being 6 once, 28, 17, so y equals 17, x equals 4, and that looks like x equals 4, y equals 17, looks like letter B. Again, I'm skipping around, I'm just doing several different ones, trying to skip through them pretty quickly. Make this video as short as possible. Next one I looked at was number 8. It says let P be you are a pitcher and Q be you are on a baseball team. They want you to write the inverse. So with the inverse, remember inverse negates both parts. So it would say if you are not a pitcher, then you are not on a baseball team. And we think about it, if you are not a pitcher, then you're not on a baseball team. Well, that's false. So we look for this and false down there in our answers. And looks like if you're not a pitcher, then you're not on a baseball team. False. It looks like letter C. Skipping to number 11. Says, if possible, use the law of syllogism to write a new conditional statement. Number 11 says, and I'm going to write this real quick, if figure is a square, then is a rectangle. Then the second part says if figure is a rectangle, then 4 right angles. And using the law of syllogism, remember with the law of syllogism, this has to say the same thing as this, which it does this time, and if that's the case, then we can take this hypothesis and put it with this conclusion and have a valid conclusion. So if it's a square, then 4 right angles. Let's see if that's one of the answers down there. If figure is a square, then it has 4 right angles. Looks like letter C. Jumping to number 15. Says use H to represent the hypothesis, C to represent the conclusion, then rewrite the conditional statement in if and then form. So all 16-year-old people can drive. So if 16 years old, then can drive. That'd be part of our answer. That's the if and then statement. Probably written a little better down there. And on that, 16 years old, this is the hypothesis. That's the conclusion. And let's see if that's one of the answers down there. It looks like letter B. Going on, number 18 says state the law of logic that is illustrated. Number 18 says if you are 16 years old, then your parents will buy you a cell phone. If your parents buy you a cell phone, then they will buy you an iPhone. So I'm just going to write like this. If 16, then phone. If phone, that's supposed to be then iPhone. Again, this is using the law of syllogism because this part's the same as this part. So we can make a statement using this hypothesis and this conclusion together. And that'd be the law of syllogism, which is letter A. Number 20. 20 says, if you have a doctor's appointment, then you will miss half day of school. So I'm just going to write it this way. If doctor, then miss half day. And then the second part said you had a doctor's appointment. So there's telling you that you had to go to the doctor. From this, notice it's not 2 statements like up here, it's just 1.5. So this is using the law of detachment, which would be letter B. Next one, number 22. 22, they give you, it says decide whether you're using inductive or deductive reasoning. Remember, inductive uses patterns, deductive uses some kind of rules or facts. 22 says your teacher drinks 1 cup of coffee each morning, so tomorrow morning your teacher will drink 1 cup of coffee. Well, that's using inductive reasoning. And there's 2 inductive reasonings down there, and it would be letter B. And you could actually get rid of some of those answers. So like when it shows deductive reasoning and then it says patterns, well, deductive reasoning doesn't use patterns. So that one can't be right. And then when it says inductive reasoning and it says you're using facts or rules or whatever, well, that's not right either. Inductive uses patterns, deductive uses facts. Next one, 26. 26, they give us this and want us to tell which property they're using. Angle EFG is congruent to angle EFG. Anything equals itself, that's a reflexive property, so the answer to that one is letter A. 28. 28 says segment EP is congruent to segment BE, then segment BE is congruent to segment EP, and all they did there was they switched them around, so that would be the symmetric property, which is letter B. Problem 30 looks something like this. They tell us this is 4x plus 34, and this angle over here is 54. Those two angles are vertical angles, so they have to be congruent. So 4x plus 34 has to equal 54. We subtract 34 on both sides, we get 4x equals 20. Divide by 4 on both sides, you get x equals 5. And all they wanted you to do was find x, so the answer to that one is C. (32) says find a counterexample. Conjecture is the product of a positive number and a negative, positive integer, and a negative integer is always less than either number. So we want a positive integer and a negative integer, and our answer to the multiplication problem should be less than both of them, either one of them. And you can look down through there. Well, the one that I see on there that looks like it'll work is if it's 1 and -3. So if the positive number is 1, the negative number is -3, well, 1 times -3 is -3. That's not less than -3. So our example would be, of the numbers would be 1 and -3. There's many other examples you could use, but that's the one that they have. Problem 36. 36, they give us a picture and it looks like this. That's angle 2, that's angle 3, D, A, B, and C. And they want us to say, it says, which statements, if any, about the diagram are true? So the first statement says angle 2 and angle 3 are complementary. So angle 2 and angle 3 are complementary. That means they add up to 90 degrees or add up to a right angle. We can't say that for sure because we don't know that this whole thing here is a right angle. They didn't tell us that, so we can't say it for sure. It looks like it, but we can't say it. Ray BA and ray BC are opposite rays. BA, BC, opposite rays. Remember, to be opposite rays, two rays have to go in exact opposite directions, so it'd have to look like that. So letter B is also not true. Letter C, points A, B, and D are collinear. Collinear means on the same line, so A, B, and D, they're not on the same line, so that won't work. And D says none of these. Well, that's going to be our answer, letter D. That's supposed to be D. Problem 37, that picture they give you, it's got two walls, and I probably can't draw two walls up here intersecting, but it looks something like this. You got two walls here intersecting, and they want to know what postulate they're showing there. Well, each wall is a plane, and they're intersecting at a line, so it'd be two planes intersect at a line, which is letter C. Number 40, they give us something that looks like this: 2x plus 45, 4x plus 21, 4y plus 11, and 3y plus 36. Please remember that these signs are always plus signs. Even if they look like this on the paper, it's a plus sign. Printer just doesn't like them. This one, we know these two angles are congruent. We know that these two angles are congruent because they're vertical angles. So this time I'm just going to set up this one equal to that one. So 4x plus 21 has to equal 2x plus 45. And I'm going to solve that, and I get 2x, and I'm solving this real quick. Plus 24, x equals 12. If I look down there at my answers, there's two of them that's got x equal to 12, so then I have set up an equation for y to figure out y. Well, these two angles are vertical also, so 4y plus 11 has to equal 3y plus 36. Solve this real quick. Y equals 25. So x equals 12, y equals 25. That looks like letter C. Number 41. They give you a picture. It looks like this. Well, yeah, and they tell you that this airplane flying up through here bisects this angle, so this angle has to be congruent to that angle. And they tell us that this angle is 6x, and the other airplane went 3x plus 9. So those two are just going to be equal to each other. 6x equals 3x plus 9. We solve here and we get 3x equals 9. And divide by 3 and you end up with x equals 3. And they just ask you to find the value of x. So it's 3. 44. They want you to find the pattern. Start off and it looks something like this. That one's colored in. Then it does this. And this block's colored in. And then it does this. And this block's colored in. Then it, our next one in the pattern then should look something like this. And this one should be colored in. So that would be our answer. 48. 45 through 48 just says find the negation of each one. The statement is the flower is red. The negation of that then would be the flower is not red. Don't change the color of the flower or anything else. It's just got to be it is not red. Problem 50. When I write these, you should probably write them better than what I'm going to write them. Our original statement says if two angles vertical, then congruent. I'm just shortening this way up, and you should probably write it out a little better than what I'm going to. We want the converse, the inverse, and the contrapositive. Converse, remember, just switches the hypothesis and the conclusion. This is your hypothesis. That's your conclusion. So converse is going to say if, and we're going to leave the two angles in the first part so the sentence makes sense. Two angles congruent, then they're vertical angles, and they want us to tell whether each one's true or false. And we look at this, and if you have two congruent angles, does that mean they have to be vertical angles? No. So that's false. The inverse goes back to the original and negates both parts. So it says if two angles are not vertical, then they are not congruent. And again, they want us to tell whether that's true or false. So we think about this for a second. If two angles are not vertical angles, so we got these two angles and they're not vertical angles, does that tell us for sure that they're not congruent? No, they could still be congruent. So that's false. And then the contrapositive is going to say switches, the contrapositive switches and negates the hypothesis and the conclusion. So if two angles not congruent, then not vertical. We're trying to tell whether it's true or false again. So we got these two angles and they're not congruent to each other. Does that tell us that they can't be vertical? And that one is true. They can't be vertical if they are not congruent. Problem 54 says identify the hypothesis and the conclusion. So the first one they give you says a quadrilateral has if a quadrilateral has four congruent sides, then it is a rhombus. So the first answer, a quadrilateral has four congruent sides. That's your hypothesis, so that's A. And then the quadrilateral is a rhombus. That would be your conclusion, and that's B. So two different answers there. Flipping over 56. 56, I give you a picture, it looks like this. Do a bunch of extra stuff in there just to try to confuse you. This is O, P, and N. They tell us in the given information, measure of angle LMN, that's that angle, is 43 degrees. Angle LMN is congruent to angle OMP, that's that angle, so if that one's 43, that one's got to be 43 degrees. And they want us to find NMP, so they want us to find that angle right there. Well, we know those three angles together should add up to 180, so if I add those two, it's 86, and then subtract that from 180, that should give us our answer. If I borrow there, that's 4, to borrow here, so that's 94. So measure of angle NMP is 94 degrees. Jumping down to number 60. Says if RS equals 7, RT equals 5, and ST equals 12, what is the relationship between R, S, and T? So we're going to draw some segment here, and it's got 3 points on it, and it doesn't have to look perfect. Don't put this point right in the middle because they didn't tell us it bisects it or it's a midpoint or none of that stuff. So if we're looking at this, ST is the longest one, so ST, that's that whole thing. We know it's 12. Then it says RS is 7, so R would have to be here, and this part's 7. And RT is 5. Notice mine doesn't look correct. It should probably be the other way around, but that doesn't matter. So it should look something like that. And what this tells us is that R has to be between S and T. And if I look down there, point R is between S and T. That's letter A. It's the only way it'll work out. Number 63. Number 63 says, consider these two statements, select all that are true statements. So, first of all, P says a square is a rectangle. Well, that's a true statement. And then Q says a triangle is a parallelogram, and that's a false statement. Then we're going to go down through and do each one. Letter A says not P. So not P. If P was true, then that means not P has to be false. So A won't work. We just want the ones that are true statements. Then the next one says not Q. Well, if Q was false, then not Q has to be true. So B is one of our answers. Then the next one says P, and then it's got that symbol Q. Remember, this symbol means and if it's and, both parts have to be true for the whole statement to be true. So P is true, Q is false. Well, then that tells us that the whole thing is false. So that one won't work. D says it's got this symbol with that, and Q, remember this means or, and when it's or, then one part or the other part. Either one's true, then the whole thing's true. So P we know is true, Q we know is false, but one part's true, so that means the whole thing is true. So that one works. Then we go to E, and it says P, this symbol, then the little tilde and Q. So P, at first this symbol means and. P we know is true. This means not Q. Well, Q was false, so not Q has to be true. Both parts are true, so that means the whole statement is true. That's another one that works. And then the last one, F, says not P or Q. Well, if P was true, then not P has to be false. And if Q looking up, back up there, was false, both parts are false, so then this whole thing is false, so that one won't work. So our answers are B, D, and E. B, D, and E. 65. Yeah, we already did one like 65, I'm skipping it. 67. Which statement follows using the law of syllogism? So they say, if quad, and again I'm writing this out very short, is a square, then 4 right angles. Next part says, if quad has 4 right angles, then rectangle. Using the law of syllogism, if this part is the same as this part, which it is in this case, then we can put this with this and draw a valid conclusion. So if a quadrilateral is a square, then it is a rectangle. Let's see, quadrilateral is a square, then it's a rectangle, that's letter A. 68, on 68, first part, one example is blank to prove a statement is true. Again, to prove a statement is true, you need all the examples. So the answer here would be insufficient, B. And then the second part, one counterexample. Remember, it only takes one counterexample to prove a statement is false. So one counterexample is sufficient to prove a statement is false. So the second answer would be A. Number 72. Need to be able to draw these pictures. What they're saying, it says point C is the midpoint of segment AB. So I'm just going to draw segment AB, AB. Point C we know is the midpoint, so those two segments have to be congruent. Point B is between, so point B is between A and D. So that means D has to come out here somewhere. I don't know how far out it goes or anything, but I know it's got to be out there somewhere. And I don't know that this segment's the same as these other two, so don't mark that. If segment AD, so from here all the way down, is 15, and segment BD, that's just from here to here, is 7, what is segment CD? So we're looking for the length of segment CD. So from here to there. Well, if we look at this, the whole thing is 15, and this part is 7, so we can do 15 minus 7. That gives us 8. That tells us from A to B is 8 units long. So that's the length of segment AB. Well, we know that C is a midpoint here, so that means it has to split it in half. So if that from here to here is 8, then each of these parts have to be 4. Now to find CD, we know that CD from C to D, that whole thing there, is segment CB plus segment BD. Well, we know CD is, or CB is 4, BD is 7, so we're just going to add those two together, and that tells us CD must be 11. Problem 75. They give us a picture, it looks like this. Sorry, that's pretty ugly. And they say that this is a right angle, and they tell us angle, this is A here, E there, B, this is C, and this is D. They tell us that angle AEB is 37 degrees, and they want us to find this angle. We know that these three angles together got to add up to be the straight angle, or 180 degrees. So if I add these two, this is 90, that's 37. So 90 plus 37 is 127. And if I subtract that from 180, that should give us our answer. We'll borrow here. That's 3, that's 5. So 53 degrees should be our answer. Problem 76. They give us all of this, and I'm not going to draw all these pictures. There's 4 of them there. And we look at it, and it goes, this is 1, that's 1, and we could do this without, this is number 2, that's number 3, that's number 4. And there's 3 dots in this one, 6 dots in this one, and 10 dots in this one, and we're looking for numbers, what did it say? The 6th one. So here's number 5, here's number 6. We're looking for how many dots are in this one right here. Well, we can just go by this pattern without actually drawing it. If you need to draw it, then draw it. But here all it does is it went up 2 there, went up 3 there, went up 4 there. So here it's going to go up 5, so that one's going to be 15. Next one's going to go up 6, so that one's going to be 21. That's how many dots are going to be in that number 6 one, and we really didn't have to draw it. Number 81. They give you a picture, it looks like this. I'm not going to put all the letters on this. They tell us that angle EFG is 27, that's this angle right here, 27 degrees. Angle GFH is this angle, and it's 65 degrees. And they want us to find the whole thing. Well, all we're going to do there is just add those two together to get that whole angle. So that's 12, 92 degrees should be our answer. So that whole angle right there, this plus this should equal that whole angle, angle addition postulate. Number 84. Number 84, this problem, they didn't really explain it completely what they want. It says how many line segments will be needed to create step 4 in the sequence. I'm thinking they want the total. So if I look at step 1, it took 2 line segments. Step 2, it took 6 line segments. Step 3, it took 14 line segments. Step 4 is what we're looking for. And there's not really enough there that I want to say, okay, well, here we went up by 4, here we went up by 8. Next one, I don't know, does it go up by 16? Does it double? Whatever the last one was, I think we would need another one. But if you look at the picture, you know you're adding on 2 for each point out there on the end. So if we just count the points out there on the end and go by 2s, 2, 4, 6, 8, 10, 12, 14, 16, to get to this next one, we're adding on 16 more line segments. So the total line segments that it'd take to draw step 4 would be 30. They didn't really explain it well enough if they wanted this number or if they just wanted how many new line segments you're adding on. So I would think that 30 is the correct answer, but might accept it if you put 16 also. 85 says write as a conditional statement. Remember, a conditional statement is an if and then statement. So 85, we're just going to say if a quadrilateral is a parallelogram, that's our hypothesis part, that's the if part, then it has 2 pairs of parallel sides. This is our hypothesis, and this part is our conclusion. Next one, number 89, jump into the 2-column proofs. Do a few of these just real quick. This one's one of the algebra ones, so I'm just going to start off right away, drawing my 2 columns, statements and reasons. Our first statement is going to be 2 parentheses 3x minus 5 equals negative 4. That was given to us. Number 2, we're going to distribute out there, so that's going to give us 6x minus 10 equals negative 4. And we use distributive property. Number 3, we add 10 to both sides, so we end up with 6x equals 6. There we used addition property of equality. And then we divide both sides by 6, so we end up with x equals 1. And that's just division property of equality. And that's all we had to do on that one. Next one, jumping to 91. 91, they give us a picture, it looks like this. As soon as I see a picture it looks this way, I start thinking of segment, addition, postulate. The given information says segment AB is congruent to segment CD. Well, if I look at this, this segment from here to there plus this segment has to equal the whole thing. And if I go on the bottom side, this segment plus this segment has to equal the whole thing. Well, I already knew that these two were congruent, and all I did was add segment BC to both of them. So this whole thing from here, from A to C, and this whole thing from B to D, those should be equal, and that's what we're trying to prove. So we should be able to go through and do this two-column proof. Statements, reasons. Our first statement is going to be segment AB is congruent to segment CD. That was given to us. And the next thing I'm going to do with that is I'm going to change it to algebra form. So AB equals segment CD, or CD. And remember, our reason there is definition of congruency. And if you write some of the other things, I would probably accept it. That could mean that same thing. Then the next thing I'm going to do is I'm going to do this. This segment AB plus segment BC, so segment AB plus segment BC equals the whole thing, segment AC. This segment plus this segment equals that whole thing, and that's just segment addition postulate. And I'm going to do that same thing again, except on the other side. So segment CD plus segment BC. I don't want to turn stuff around. So segment CD plus segment BC equals the whole segment, which is segment BD. And again, that's segment addition postulate. Number 5. Once I have all of this, if I look at all this stuff that I have right here, I know that AB and CD are the same thing. So if I take out CD right here and stick AB in its place, I end up with this. AB plus BC equals BD. Oops, BD. So all I did there, so I was looking at this number 4 right here, and I knew that AB and CD were the same thing. So I took out CD right here, and I stuck AB in its place. Well, now you look at what we have in 3 and 4, in these two. We know that AB plus BC equals AC, AB plus BC equals BD. Well, this and this are the same, so that means these two things have to be the same. So number 6, AC, and I forgot my reason on number 5, I'll do it here in a second. AC has to equal BD. Number 5, our reason was just substitution property. And our reason for number 6 is also substitution property. We took out something and stuck something else in its place that was the same as it. And then to get to what we're trying to prove, we just got to switch it back to geometry form. So segment AC is congruent to segment BD. And our reason is going to be definition of congruency. If you have to pause it because I go too quick, then pause it. '94. '94 looks like this. That's P, Q, R and S. They tell us Q is the midpoint of PR. So Q is the midpoint of PR, so that means this segment's congruent to that segment. And they tell us that R is the midpoint of QS. So that means these two segments have to be the same. I already have one mark on this one, so to mark this one, I just put one mark on it. And now that tells us that all three of these segments are the same. And what I'm trying to prove is that this segment, PQ, is congruent to segment RS, which I sort of just did. And we did that by substitution, so we should be able to go through and do this two-column proof. Again, we could use segment addition postulate on this, but there's a shorter way, and that's the way we're going to do. So we know Q is midpoint of segment PR. That was given to us. Notice I don't go right to the next given. Next thing I'm going to say is once I knew Q was a midpoint, I knew these two segments were congruent. So segment PQ is congruent to segment QR. And our reason for that is because what we said in number one here. Midpoint splits segment into two congruent segments. Midpoint splits a segment into two congruent segments. Now I'm going to go back to the other given, and they told us R is the midpoint of segment QS. That was given to us. And once I know R was a midpoint, then I know this segment and this segment were congruent. So segment QR is congruent to segment RS. And our reason there is same as number two up here. Midpoint splits segment into two congruent segments. Sorry, that's sort of ugly. Now, if I look at what I have here in 2 and what I have here in 4, well, both of them have QR in it. So PQ is the same as QR, and QR is the same as RS. Then I know that segment PQ has to be the same as segment RS. And there, we used the transitive property, but better thing to put, substitution property. We just took out one thing, stuck something else in its place. And we didn't have to go through and use the segment addition postulate. Next one, number 96. They give us a picture, it looks like this. It's angle 1, angle 2, angle 3, and they tell us angle 1 and angle 2 are supplementary. Well, we already knew that, so these two are supplementary. And then they also tell us angle 1 and angle 3 are supplementary. So those two are supplementary. That we didn't know, but 1 and 2 we could have picked out from the picture that they had to be supplementary. But we had a theorem that said if one's supplementary to 2 and one's supplementary to 3, then 2 and 3 have to be the same. They have to be congruent, and that's what we're trying to prove. So we should be able to go through and do this two-column proof using that theorem. Number 1, and I'm going to write this a little different than what they write it just to shorten it up. Angle 1 sup to angle 2. How do we know that? It was given to us. And number 2, angle 1 is supplementary to angle 3. That was also given to us. So now what we have, if angle 1 and angle 2 add up to 180, angle 1 and angle 3 add up to 180, then that tells us 2 and 3 have to be the same. So our next thing here is angle 2 is congruent to angle 3, and our reason is going to be one of those theorems that we had, and the shortened form that I gave you was angles supplementary to the same angle are congruent. If two angles are supplementary to the same angle, then they have to be congruent. And that's all the farther we had to go on that one. Number 98, this last one that I'm going to do, they give us a picture and it looks like this. This is angle 1, that's angle 2. This is angle 3, that's angle 4. And they tell us that angle 1 is congruent to angle 3. So this angle is congruent to that angle. Well, we already know that angle 1 and angle 2, they're vertical angles. So they have to be congruent. So I can put the same markings on angle 2. So now I know 1, 2, and 3 are all congruent. I'm trying to prove 2 and 4 are congruent. Well, 3 and 4 are also vertical angles. So they have to be congruent. So that tells me that all 4 of these angles have to be congruent. And then I can say angle 2, by substitution there, angle 2 is congruent to angle 4. So we should be able to go through and do this. Statements, reasons. First statement, angle 1 is congruent to angle 3. That was given to us. Then I said that angle, and I'm going to do this a little backwards because I already have angle 3 right here, so I'm going to do angle 3 is congruent to angle 4. And we know that because vertical angles are congruent. Now, if you look at what you have here, you know 1's congruent to 3, 3's congruent to 4. Then we can go to the fact that angle 1 must be congruent to angle 4. And all I did there was substitution property. We always want to go in some kind of sensible order. Now, once I had that, I also knew that angle 1 was congruent to angle 2. If I look back up here, those were vertical angles. So I just have vertical angles are congruent. Now I know 1 is congruent to 4, 1's congruent to 2. Well, that tells me that these two have to be congruent, so, and I'm going to write it in the correct order so I don't have to use symmetric property. Angle 2 is congruent to angle 4, and all we use there was substitution property. Took out one thing, stuck something else into place. Hopefully that helps a little bit.